Hi everyone. So we've been learning about radicals, and first we learned about square roots, and then in our last lesson we learned about other radicals like cube roots and fourth roots and fifth roots, things like that. Now today what we want to do is talk about how to simplify those other types of radicals. So when we did simplifying with square roots, what we did is we looked for perfect square factors that we could divide out and turn those into whole numbers. Now with a cube root, which is what we're going to start with, it's the same concept, but we're looking for perfect cubes instead of perfect squares. So let's start out by listing some perfect cubes. We already did this with perfect squares. And remember, to cube something means to raise it to the third power or to multiply it by itself 3 times. So if I start listing some perfect cubes here, 1 to the third power, well, that means 1 times 1 times 1, and that's going to equal 1. So basically 1 to any power equals 1, and we don't even worry about that when we're simplifying because dividing by 1 doesn't simplify the number anyways. So let's get to our first real one. 2 cubed, that would be 2 times 2 times 2. Well, 2 times 2 is 4, times 2 again is 8. Then you have 3 cubed, 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Let's go with 4. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 again is 64. Let's do 5. 5 times 5 times 5. 5 times 5 is 25. Times 5 again is 125. Now all of a sudden they're getting pretty big. I'm not going to go too much farther than this. 6 cubed ends up being 216. 7 cubed is I think 343, but we're getting too big there. We're not gonna go probably past 5. One thing I will say though, 10's an easy one for any power. Oops. 10 cubed, 10 to the third power, 10 times 10 times 10 is just a 1 with 3 zeros after it. So 10 cubed is 1,000. That's another easy one to simplify. But basically, those are the factors you're looking for. If we're trying to simplify a perfect cube, we're trying to find one of these factors, one of these perfect cubes to divide by. So for our example today, we're only going to do one. Let's do, it's kind of a review of what we had been doing and what we're doing today. Let's take the same number, 24, and let's simplify first the square root of 24, and second the cube root of 24. Now both of those questions have to do with a factor tree for 24. So let's start with that. 24 could be 1 times 24. It could be 2 times 12. It could be 3 times 8. It could be 4 times 6. Not 5, that doesn't work. And then we're back to 6, so we know we're done with our list. So that's our factor tree for 24. Let me start with the square root of 24. Not the cube root, but the square root, what we did last week. So if I'm doing the square root, then what I'm looking for is a perfect square factor. And the biggest perfect square factor I see for 24 is the 4. So I say, okay, well 24 is 4 times 6. Let's split that up. I'm going to write my 24 as 4 times 6. I'm going to split it up into 2 separate radicals, the radical 4 and the radical 6. And then remember, the one we picked, the 4, is a perfect square, so that simplifies. We say the square root of 4 is 2, and the square root of 6 is the part that doesn't simplify, so we leave that in our answer. So our simplified answer for the square root of 24 is 2 radical 6, or 2 times the square root of 6. Now, let's do the same thing with the cube root of 24. Now it's the exact same concept, but I'm looking for different numbers this time. See, right now, I'm not looking for the 4. 4 is not a perfect cube, it's a perfect square. Now, if you think of that list we just went over on the last slide, the number I'm seeing is the 8. 8 is a perfect cube because it's 2 cubed. It's 2 times 2 times 2. So instead of splitting it up into 4 times 6, I'm going to split it up into 8 times 3. And then I'm going to separate. Now when you separate, they are both cube roots. The radical stays the same in this problem. So it becomes the cube root of 8 times the cube root of 3. And then same thing we just did with the square root. The first one simplifies. The cube root of 8 is just 2. That's why we picked that number. The second one we leave. The cube root of 3 stays part of your answer. So you can see the problems are very similar. You're just using different numbers. You're looking for perfect cubes instead of perfect squares. So the square root of 24 simplifies to 2 square root of 6. The cube root of 24 simplifies to 2 cube root of 3. But it's a very, very similar question. You're looking for either a perfect square or a perfect cube. Separate the number, simplify the one, leave the other.